Hi there, my name is Andrew Keat, and today I'm going to be talking about the Intertropical Convergence Zone, or the ITCZ. So let's take a look at a definition of the ITCZ. It is a belt of low pressure which circles the Earth near the equator where the trade winds come together. It is formed by vertical motion and characterized by convective activity, which often generates storms over very large areas. If you will humor my artistic capabilities for just a second, here we have a drawing of the Earth, and this red line is the position of the ITCZ during the Northern Hemisphere summer, and this blue line is the ITCZ during the Southern Hemisphere summer. And it might not be drastically clear from this, but in the Northern Hemisphere summer, the ITCZ will actually migrate further north of the equator than it would do than during the Southern Hemisphere summer. And this is because the Northern Hemisphere is very land heavy. But in general, the ITCZ follows the zenith of the sun, and it will migrate in accordance with that. So let's take a look at how the ITCZ is formed. Here we have two Hadley cells, which are either side of the ITCZ. And in between these two Hadley cells, we have an area of low pressure. And at this area of low pressure, we have very hot, warm, and still air. And this air rises, and it cools and expands. And as it does that, it forms a lot of clouds, a lot of precipitations, and there are a lot of thunderstorms in this area. And also, at this point, as the heat is rising, some of the heat radiates out to space and is lost. So then this heat, this warm air that is cooled as it has risen, it travels from this area of high pressure up here to an area of low pressure either side as it moves towards the tropics. And as it does that, it obviously loses its precipitation through all the thunderstorms, and it becomes cool and dry air. Now this cool, dry air in an area of low pressure, it then starts to sink, it subsides, condenses, and warms. And over an area of subtropical, it moves down to an area of subtropical high pressure. It is around these regions, 30 degrees north and south of the equator, that we actually get areas of desert, as the air is very cool and dry. And these areas become very hot during the day. And so then as the air moves to this area of subtropical high pressure here, the trade winds then carry it back towards the convergence of the two Hadley cells, which is the Intertropical Convergence Zone. And as these trade winds come together, we actually get an area of stillness, usually about 5 degrees north and south of the equator. So we have this 10-degree band where the trade winds meet. And it's very still air, and this is what is called the Intertropical Convergence Zone. And as I said before, the latitude of the ITCZ varies depending on the season. And so now let's quickly take a look at these trade winds that bring the air back towards the ITCZ. In the Southern Hemisphere, we have southeasterly trade winds, and in the Northern Hemisphere, we have northeasterly trade winds. And as you can see here, both of these trade winds curve towards the west, and this is due to the Coriolis effect, which I discussed in my last video. And so that is basically how the ITCZ is formed. Thank you very much.